Hello. Happy Wednesday. It's Wednesday, I'm pretty sure, right? I can never remember these things anymore. Dripping water all over myself. That's fine. Where do I want to put this? My life is a mess. Okay. Um, Today we're going to do the perfect shuffle challenge, which will be great. I have cards, but we're not actually going to use cards. We're going to play with Excel. Because this is a theoretical thing. A perfect shuffle is when you take two halves of a deck and perfectly riffle them so that uh, the the top, well, they perfectly alternate one to the other. And I can't do that. So that's fine. We're just gonna try to do this all in Excel. Um, I have the whole challenge written out, took from a website. It's also written down in the description. You can read that there. But first, since I think I'm all alone right now, I'm going to start setting up some preliminary. Here's the challenge. See, but I'm going to read that off in a second. In the meantime, why don't we start off with a little just the preliminary stuff, the first steps. But so basically, we're going to have a deck size, and we're going to have a number of shuffles. Um, Given a deck size, which is even and between 2 and 200, we need a predicted number of shuffles. Um, so that will all make more sense in a second when I read off the challenge. Uh, but we're going to have some different columns here. This is shuffle number 0. Why don't we go like this? We're gonna center all of these things, and center this too. Great. Um, and these are going to be our titles. This is going to be our answer, and this is, so if, say we shuffle 0 times, what do the cards look like? Say we shuffle once, what do the cards look like? Say we shuffle twice, and so on and so forth. Um, This could also be called our index, and this is going to be our lookup, and this will all make more sense. This is things that I've based on. I'm hoping this is all going to work, but I think that basically all we got to do is figure out what the deck looks like before we shuffle anything. Okay, and that's really easy. That's just counting from 1 to however big the deck size is, and then what it looks like after we shuffle it once, and then the rest of these are going to be really, really stinking easy. Um, we'll just, you know, keep on sorting that out. So let's read the challenge real quick. Boo, boo, boo. A perfect shuffle is a trick used by card sharks and magicians to give the illusion of randomness when in fact the order of the cards is being controlled. It involves cutting the deck into exactly equal halves and then perfectly interlacing the two halves one card at a time. I don't know if anybody can actually do that. So for example, if a deck contains 52 cards, numbered in order from 1 to 52, the deck will be cut into a left half, which is numbers 1 through 26, and a right half, which is numbers 27 through 52. They are merged from the bottom up, starting with the bottom right card 52, and then the bottom left card 26, and so on and so forth. 51, then 25, all the way up. So the deck is going to be in the new order of 1, 27, 2, 28, 20, and so on and so forth until 25, 51, 26, 52. So if you have a deck of 52 cards and repeat the perfect shuffle 7 more times, the deck will be back in the original starting order. So for a deck of 52 cards, 8 perfect shuffles will leave the deck in the original order. So for us, if we were to put in the number 52 here, we want Excel to print out the number 8 here. But it doesn't do that yet, of course. All right. Here's our challenge. Build an Excel workbook that will model a perfect shuffle for every even-sized deck from 2 to 200 cards. So we need to be able to put in anything from 2 to 200 that's even in this cell right here. What's the smallest number of perfect shuffles required to get the deck back in the original order? 4 cards, the answer is 2. For 52 cards, the answer is 8. What about other deck sizes? Try to find the simplest and most elegant way of modeling this that you can. Try also to find interesting ways to display the answers and highlight any patterns you see emerging. Bonus points if you can spot any pattern. Is there any way to model this for a deck size of 20,000 cards? All right. So we're going to start. We're going to start this puzzle. Am I going to be alone for this whole thing? I very well might be. Okay, so first of all, we have to have up to 2. Whoops, this is supposed to be up to 200. We have to have up to 200 cards, right? So let's bring this all the way down to 200 so we have all the room that we need to play with. Okay. And there we go. We've already finished the first row. We're so good at this game, guys. Good work. I'm also going to, let's see here. I'm going to freeze panes right here so that if I scroll down, I always have this up top. And if I scroll to the right, I always have the index and the lookup. So my thinking is, so we shuffle this, and after that we'll have the new order, right? And so this is going to be a 1 still, right? Is that what we're saying? Yeah, so 1 is always going to be 1, right? This is always just going to equal that. But this, depending on what's going on, like if we've got 52, then this is going to end up being a 26 here. No, this was going to be a 27, right? Yes. And that's fine. And then also we're going to have some number down here, x. This is going to be some number, okay. That's going to be in the 27th spot. So when we come over here, this is always going to be able to come back and say, hey, what's in the 27th spot now? This card is going to move up to here. And then this card is going to move up to here. And so we can use this column. Once we have formulas figured out for this column, then everything will be much easier to puzzle through. So we just got to figure out the formulas for this column. And for the very first cell, for card position number 2, I think this is always going to equal our original amount divided by 2 plus 1, right? That gives us 27. That gives us 27. If this is a 200, then this is going to be 101, right? And that makes sense. Excuse me. If this is a 2, we don't even shuffle anything, do we? Did they tell us that? For 4 cards, the answer is 2. For 2 cards, the answer is 1. Okay, great. All right, great. Great. So I think we're in good shape here. Assuming this is, we might discover this as problems later. All right, what's the third card going to be? The third card is always going to equal, well, in the first shuffle, the third card is going to equal, I think it's just going to equal, it's just going to be the second card, right? It's going to equal the second card, I think. And then this is going to equal 52 divided by 2 plus 2, right? And then this is going to equal our third card, right? And I think this pattern is going to continue on 4 forever. Oh, why doesn't it? B5. Oh, right, because I need to I need to add in the dollar sign so it doesn't move. Add in the dollar sign so it doesn't move. So now, will this formula? Nope, it won't. It sure won't. All right. It sure won't. Okay, so I want to reproduce these formulas so that this, every other step, it goes up 1. And this, every other step, it changes this number from 1 to 2 to 3. And the problem I'm having here is our odd cards are working not fine at all. What? That's frustrating. That's real frustrating. Okay, because this skipped up 2. No, this skipped up 3? Why did this go all the way up here? That's really bizarre. And this is going here now? This is going here. Oh, because it's going 1 to the left, and then it's going up like this. This is going 1 to the left, this is going left and up. This is going 1 to the left, this is going left and up. All right. That's fine. It's got to be a simpler way to model this. What if we do? Man, I don't want to have to manually type this all out. Here, this is going to make life a little bit easier. Instead of 1 like that, we're going to tell it to look up that. And then we're going to tell it to look up that. And I'm hoping that what that will do for us is maybe it'll learn the pattern here. Nope, it sure doesn't. It sure doesn't. See, it just goes across, and then it goes down like that. Okay. Okay. I've got an idea. I've got an idea. All right, we're going to create a brand new. Okay, so this is the model. We're going to do some background work here. Okay. This is background. There's a better name for that, but that's fine. All right, so this is just numbers from 1 to 200. Let's center all this and make it look pretty, and we'll bold this up here. Excuse me. That felt odd. That felt real odd. All the way up to 200. Great. All right. So what we want is when it's an odd card, we want it to follow one pattern. And if it's an even card, we want it to follow a different pattern. See? This is going to become a very unwieldy formula really fast, I can tell. That's miserable. Okay, fine. That's fine. So this is the odd pattern, and this is the even pattern. Okay? The odd pattern is really simple. Sort of. So 3 becomes 2, 5 becomes 3, 7 becomes 4, 8. Oh, great. it's going to equal. Okay, so let's pretend that an even card followed the odd pattern. What would happen? Well, we would get. We're going to do this. We're going to do this. This is my plan. It's going to be this divided by 2 plus 0.5. Okay, and what that is going to do for us is whenever it's odd. See, look, we've got 3 is turning into 2, like we need. We've got 5 is turning into 3. We've got 7 is turning into 4. Yeah, great. Great, 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 great. All right, now if it's even, and this can count up even past our model size. Yes, 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 yes. I wonder, is there an if odd function? If even? We'll get to that in a second. All right, now if it's even, what's the pattern? The pattern is we still want this number, okay, divided by 2 plus the same thing. Wait, plus the indexed divided by 2. That's all we need. Yeah. Yes, yes, yes. This is great. This is great. All right. So if it's even, we just want to add half of this and this. Okay. Great. So it equals 52 divided by 2. So this goes up by 1, this goes up by 2, but it's always going to be plus this divided by 2. And now look at this. Look at this. What? Why? All right, because this needs to not move. Great. See? All right. So now it just needs to choose. It needs to know to choose the one that isn't a weird weird decimal. Okay. 1, 27, 2, 28, 3, 29, 4, 30. And we can continue this all the way down. And we can also, look at this. Let's just change it to, let's say there's only 26 cards. All of a sudden, this changes. Now we've got 1, 14, and that makes sense, right? Because half of 26 is 13, which means the first half of the first card of the second half is going to be card 14. Great. Great, 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 great. So we just have to tell it when this is odd to look up here in the odd pattern, and when it's even to look up in the even pattern. That should be pretty doable, right? I think we can do this. So now equals is integer, is even. Yes. All right, great. Watch this. Watch this. All right. See even test. We can simply this is going to go false and true, false and true, false and true. All right, great. So we're not actually going to use this column, but now we've got a test that's, oh gosh, guys, this is so easy now. All right, all we have to do, we have to go equals is even if, first we need an if statement, all right? And then we're going to say our if statement, our test is even, okay? And that's all. Great. So if it's true, then what we want it to do is do a VLOOKUP. Have you seen VLOOKUPs before? And it's going to take this value right here. It's going to come over to this table. And it's going to take the third one. And I almost always do false. What? Oh, right. Great. Great, 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 great. So, if statement is even as a test. If it's false, that means that, well, this is what it does if it's true. If it's true, that means it is an even number, okay? And yada, yada, yada. We need to tell it what to do if it's false. If it's false, that means it's odd. That means we do something very similar, except we do a VLOOKUP of this same, we need to take this 1 again, and we need to come over here. If it's false, that means it's odd, so we just need that bit of the table, and we tell it to look into the second column, because B is the second column of this table. Where am I? 2 and false. Yes, 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 yes. Great. And now look. Look, 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 look. This is so simple. If it's 28. Great. This is simple. We can get rid of this because we're not actually using it. That was just testing things out. All right. And then we just move this all the way down to 200. And then we can move this all the way down to 200. Great. That, so obviously after we get to card number 28, this starts not making sense, right? This is gibberish. That's fine. Okay. Now, all we do, okay, so this is what no matter what we put in here, hold on, why don't we make it this a little bit more elegant? Because I don't want all of this to show up, because this is all gibberish, remember? These are, I mean, there is no card 7 when the deck size is only 4. So we're just going to make this even more complicated here. You ready? Equals if, okay. And what we want it to do is once this card, once the index card is bigger than the deck size, that we want to print that, you know, we want the test to stop working. We want it to print NA, okay? So if the index card is greater than the deck size, then print for me NA. Thank you. If it's not, then you can do all this other gibberish that we taught you. Oh, I don't know if you can see. I don't know if you can see all of this. This is an ugly, ugly formula. Here, I'll copy and paste this into a notepad real quick. Cancel. Fine. You know what? Notepad like that. Bring this over. Control A. Why doesn't Control A work? That surprises me. You'd think I'd know these things, but oh well. Okay, this is what it looks like. What happened? What happened? Book 3. That's very strange. Okay, whatever. This is what it looks like. Now the only problem is we want B1 to never move. So I'm gonna go back in and I'm just gonna add in a $sign right there. And oh, right. I accidentally, okay, we're just gonna copy all of this and we're gonna paste it here. And now when we get to 5, see, look, see? Now when we get to 5, it, oh shoot, I lost all of the windows that help me know what's going on. All right, there's this. But when we get to 5, it starts printing off NA. And it looks like our thing is working. Okay. My apologies. I want to get back up all of the important information so I know that nobody's dying. Because dying is no good. Great. So now we can extend that all the way down. Great. And if we do 2, then that's how, then it looks like that. If we do 200, then it all fills out. Isn't this beautiful? Oh, I love this. All right. Now, we're not done yet. Let's look at this. We're at shuffle number 2 now. So, all we need to do, let's do this cell first, because it's hard to see what's going on here since it just never changes. But so so whatever is in place number 101 now needs to come up to here. So in this case, we're gonna come all the way down to 101, and this 51 is gonna come up to here. And we can do that. I'm gonna use the SUMIF function for reasons that I'll explain in a second. And all we need to do is take this and bring it all the way down. Okay. The criteria, of course, is this right here. Okay. And the sum range is this to this. So what this is going to do is it's going to take, can you see this? This is really tiny. It's going to take, let me open up this notepad. So this is the formula we're looking at. So SUMIF, what it's going to do is it's going to look through all of these cells, B6 through B205, and it's going to try to find whatever is in B7, right? That shouldn't be B7. That should be C7. Shouldn't it? All right, cancel everything I'm doing here. Yeah, because this has to change. This should be C7. Okay, I can fix that. This should be C7. Okay, so it's going to go through all of these numbers here, and it's going to look for whatever's right here, right? And it's going to take then it's going to go through all of this, and whenever it finds, in this case 101, it's going to come over here and add that to our total here. Of course, it's only going to find one card that looks like that, and in this case, it's going to be 51. Now, now what stays the same and what changes when we come over, when we go up versus down? First, when we go up and down, we want to make sure that these blue and purple, we want to make sure when it goes up and down that this never changes and that this never changes, because that would cause so many problems. but like we're always referring to this, and we're always adding from this for as long as we're in shuffle number 2. Okay, so so that means we want to put a $sign in front of all of the numbers here. Okay, so this is what I just did. You know what I can do, actually? All right, what I'm going to do is I'm going to expand this way out this way so that you can see the formula that I'm working with, okay? Doesn't that look better? Great. All right. So now, when we drag this up, whoops, what happened? When we drag this up, when we copy and paste this up, look, we got a 1 again. When we copy and paste it down, we get 101. Why? Because it's going to find whatever is in position number 2. And what's in position number 2 right now is 101. This is beautiful. All right, but we're not done yet. Okay, we still got to figure out what's going to happen over here in cell number 3, because I want to be able to drag this way, and this is going to be gibberish. This is looking for 0 now. I have no idea how it got 0, but that's fine. Oh, right, because we haven't fixed any of these letters. Okay, so what changes? What stays the same? It's going to... All right. So our index never changes. Our index never changes. Okay, blue is our index. Our lookup position, that's also not going to change when we go to cell number 3. In other words, when we get to shuffle number 3, we want it to look for whatever's in position number 101. Still, not what's in position number 51. Hope that makes sense. Also, but what will change is is this purple. This purple needs to move over. So in other words, what it's going to do now is not work. Crap. All right. Oh, right, because there's nothing in cell 101 down here. Watch this. So we're just worried about whatever is in cell number 101. Okay. Whatever's in position number 101 needs to come up to 51. 26. See? All right. So by shuffle number 3, we're going to have card number 26 in position 2. Why? Because whatever's in position number 101 comes up. Of course, it's at the first shuffle. What's in position 101? Well, card 101. In the second shuffle, what's in position 101? Well, card 51. Okay. And in the third shuffle, what's in position 101? What's in position 101? Well, 26 is going to be there. And we know that because this is coming from position 51. Yes. All right. So all of our formulas are set. We can expand that up. We can expand that down all the way to 200. Isn't this beautiful? And now we can expand all of this over to as far as we need it. And this is freaking amazing. All right. And we're going to make this come to size. Great. All right. So for example, if we have 4 cards, this is what they're going to look like time after time. Okay. So now obviously Now we need to figure out what signals, how do we tell which one of these is right? We need this to be like, so for example, I don't like that. I don't like these zeros. You know, we can just make this a little more complicated. So if this, all right, let's come down to a 0 so we can see what's going on. So if this, and we're going to copy all this for a second. If that equals 0, then we want it to print just an NA again. And if it doesn't, it can print exactly that. See that? There we go. And then we can come all the way down, we can drag it over, and now it'll replace all of our zeros with NAs. Beautiful, beautiful. We're doing a great job. This is the nerdiest stream. I don't expect I'm going to do many more Excel streams, huh? People don't. But I love this sort of stuff. This is so much fun. Okay, so now which how can we? So we can see, right, that after 2 shuffles is good, right? We can see if we turn it to 6 that we need to go to 4 shuffles. We can see if we turn it to 8, I'm going to guess 8 shuffles? Nope, 6 shuffles. Oh, that's so interesting. 1, 2, 3, 4, 5, 6, 7, 8. I'm really curious what this pattern is. But we'll get there in a second, because I wonder, there's got to be like an algebraic formula where you can just figure out what the input number is and what the output number is. We'll figure that out later. So what we're going to do is here. We'll do something here. We'll do something here. Hold on, we'll do it here. This is our winner test. Yes? Equals if all of these equal all of these, then that means, oh no. Oh no. Actually, this isn't going to work. Why? Because we have those NAs. This would almost work. This will work when we have 200. But it's not going to work for this. I want it to be able to compare those two. And print off when it's a winner and when it's not. But see, it's trying to compare a 9 to NA now. And that's not going to work, of course. That's not going to work at all. B7 to 206. Well, what if we do this? So we want it to actually only come down to this, to cell 14. Can we tell it to only come down to cell 14? Can we change how many cells it looks in based on here? I don't know how to do that. The plot thickens. The plot thickens. I got it. What we need is some hidden cells. We need to think in another dimension. And we've got more dimensions, right? In Excel, what that can look like is another sheet. This is our comparison sheet. You probably can't read that, but that's fine. So this is our comparison sheet, and what we're going to do is we're going to have, this is going to look very, very similar to what we had going on before, but we're going to have different formulas going on. So starting in cell A4 and onwards, we want things to start copying. Okay, so equals, this is going to be a direct copy of the model. Let's make this a little bigger. Index. Yes, 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 yes. And it's going to come all the way down to 204 or 214 or something like that. How far do we need to go? No, 206. Hey, that worked out real well. All right. So now, of course, we don't actually need these zeros right here. We don't actually need all of these things. Well, these cells are going to change. These, of course, are different. This refers to nothing. This refers to nothing. Okay. And this means nothing. This cell means nothing. The shuffle 0 means absolutely nothing to us all the time. But shuffle 1 does mean something. And what we want to test is instead of just printing things off again, what we want it to do is we want to ask it equals if does, we're in C7 right now, does C7 in our model, hey, I said equals if does C7 in our model equal our index number. Yes? There's a problem with formula. I'm not trying to type a formula. I don't. Okay. If those two are equal, we're going to have it print off the number of problems. This is actually our problems lookup. See that? See that? Nope. Nope, 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 nope. Why don't we reverse these? So if those two cells equal each other, that tells us that that card is in order, and that tells us it's, and if it's not, then that tells us it's not. Okay, so we can tell that we've got two cards in order for here. Now, of course, we need to make sure that our index doesn't change ever. So B7, we need to put a $sign in front of the B. Okay, and now we should be able to drag this over and copy them down like that. And now it'll tell us on the third shuffle everything is in order here. Okay, then I want this to just equal the sum of everything below it, and this will tell us how many cards in order. So right now, cards in order. Okay, why don't we make these bold again so we know better what's going on. Okay. Great, 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 great. We can move those all over. We can come over to our model. And now, well, that's so interesting. So we've got 2 cards in order. We've got 2 cards in order, and then all of a sudden we have 8 cards in order. Then we have 2 and 2, and then we have 8. So it seems to be like an all or nothing type of deal. Is that always true? Nope. Sometimes you can have, see, that's an entirely different pattern. This has 2 in order, then it has 4, then it goes down to 2, then it goes up to 4, then it goes down to 2, and then it goes up to 10. That's so beautiful. That's so beautiful. Huh. All right. But that's fine. So now, how can we tell it's a winner? Well, this shuffle is a winner if what? If the deck size equals the number of cards that are in proper order. Winner. I'm just typing in winner, and then I'm typing in a space bar. Okay. And so it doesn't look like there's anything in the cell. Why? Because this cell is not a winner. That being said, we don't want B1 to move anywhere, specifically the B part of that, because we're going to be dragging this horizontally. And we can move this across like this. And so it found a winner in shuffle number 6. If we change this to, I wonder what happens if we give it an odd. It gets very confused. Okay, that's fine. 2 cards. Every shuffle is a winner with 2 cards. 4 cards. Every other shuffle is a winner. 6 cards. Every third shuffle is a winner. No, every fourth. Excuse me. This is great. All right. So now, I wonder if sum if works. Okay, so now what I need it to do is it needs to come along this way until it finds winner, and then it needs to move up. And I don't know how to do that. So that's a problem. That's a real problem. Any ideas out there, guys? Interesting. Interesting. It's kind of like a V lookup, but it's a horizontal lookup equals H lookup. Oh! Yes. Yes, 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 yes. Okay. H lookup. So our lookup value is winner. Okay. So this is a problem because it's going to have we need the shuffle to be underneath. Okay, we can fix that though. Okay, we're gonna add in a hidden shuffle number. This is a magic trick, right? And all this is going to do is it's going to equal this up here, and this is going to come across, and this is going to so now what we can do is we can look for winner, and then we can come down 1, and it'll print off. As soon as it finds winner, it's going to come down 1. Okay, and then what we can do afterwards is we can just hide this, but the formulas will still be working in the background. Okay, equals H lookup. I had no idea this was a thing. Okay, what we're looking for is winner. Okay, our table array is these two rows here. Okay, and we want it to print off from the second row, and we want it to be true. What that means is it's going to keep on looking until it finds it, and then it's going to stop looking. It's going to ignore everything else. If we did false, it's going to look harder. Except it doesn't. Except it doesn't. Oh, all right. No, we are making this more complicated than it needs to be. Okay, what we're going to do is a min-if function. Min-if. Okay, so the min range is here. Wait, hold on. It's only min-ifs. Okay, so what we want it to do is we want it to return the smallest shuffle number of all the shuffle numbers that are winners. That makes sense, right? So it's going to come to this row, and it's going to look in there. Okay, what's it going to look for? It's going to look for this right here, this little text that you probably can't see that says criteria range 1. So this is the criteria. We're only going to use the first criteria. This function allows us to use as many criteria if we want, but we just need one. So our criteria, what we're looking for is the word winner. Okay, and where are we looking? Whoops, nope. That's actually, we need the range there. Excuse me. Okay, so this is criteria range. So we're telling it, all right, look here for this criteria. What is that criteria? It is winner. And then we press enter, and look at that. So it's going to come along here, this row right here. It's going to look for all of the places that say winner, and then it's going to find the smallest in here that correspond. So in this case, it's going to find a winner here. It's going to find a winner here. Then it's going to compare this 3 and this 6, and it's going to say, 3 is the smallest of all those. Why don't we turn this into blue, because this is what we're looking for. Great. Great. And now all we need to do is we need to compare. We need to drag this out further. 200. See, now I can't find it. Why? Because our model's too small. So we're going to drag this way out this way. And we're up to 42. I wonder if 42 is the magic number. So we need to bring this all the way out to 42. It's fine that it goes farther. Okay, so we're ready to go all the way up to AZ. Nope, still not able to find it. Okay, so let's bring this up to AZ. Still not able to find it. Wow. Do we need more than 100 shuffles? Oops, I don't want to do that. What was that? So our model page, it was up to 94, right? So we need to drag this out to 94. Okay, so this is up to ET. Have we found it yet? Nope, we sure haven't. This 99. That's crazy. All right. Number of shuffles is 99. Let's come to shuffle number 99. So the answer to this puzzle is, if we have 200 cards, we're going to need 99 perfect shuffles to get back to where we started. That's kind of cool. But I have more questions. I have more questions. I'm going to create another worksheet here. Whoops. We're going to call this regression work, and I'll explain what this means in a second. What I want to do is I want to figure out, can we find a formula for what this number is generated, what number this is. Like, for example, if we make this 198, it finds nothing. Whoa, so if it's 198, it becomes a harder problem. 198. Whoa, that's crazy. Did you see that? So if we have a deck of 98 cards, then it takes 48 shuffles. Then if we go to 100, then all of a sudden it takes 30 shuffles. What about 144? This is a perfect square. Interesting. Oh, this is so fantastically interesting. Okay, so we've got powers of 2. There's 2, 4, 8, 16, 32, 64, 128. This has got to be a small number. 7. I wonder. Okay, so we've got 2 is the power of 1. 4 is the power of 2. 8 is the power of... What if we just do 2 to the power of 7? What does that do? 128 is 7. This is so cool. Well, so that's an interesting pattern that we can find. What if we do 0? What does it tell us? It tells us everything's a winner. Yes, of course, because there's never any problems. Our standard is 0. 9. It never finds anything, of course, with an odd deck, because that breaks the rules of the problem. Okay. So what we're going to do here is we're going to create a simple graph of two, 4, 6, 8, deck size and number of shuffles. I want to see if there's a relationship here. And we can go all the way up to 200. So this is, of course, this was 1. Well, I don't know. Maybe the deck size of 2 is going to throw things off. I'm not sure. So we're going to ignore that. Okay, so we just need to start sampling things out here. This is our input, this is our output, and what we're going to do here is we're just going to link the model into here. Okay, so the model, no longer do we input things here. Instead, why don't we gray this out? Instead, I want this to come over to my regression machine and link there. Okay, so whatever I put in this cell is going to go over onto that first page, and it's going to do all the work for us. And then this output number, this, of course, will tell us whatever the machine spits out for us. Okay, so that's 2, and this is 4. And why don't we center these things? 8 is going to be 3. Oh, that's so interesting. 10 is going to be 6. 3, 6. And then 12 is going to be 10, and 14 is going to be 12. 10, 12. What's 16? Whoops, typed that in wrong. You can tell my computer is lagging because it's doing all sorts of calculations in the background. So this is probably not the most elegant machine out there, most elegant model, because I'm working my computer really hard to get these numbers. This gives me 18. 22 gives me 6, 24 gives me 11. What a fantastically interesting pattern. Like, can you imagine somebody comes up to you and says, okay, I've got a pattern for you. 2, 4, 3, 6, 10, 12. What's next? Well, the answer is 4, and then it's 18, and then it's, no, and then it's 8, and then it's 18. And this is all based on this very strange property of stuff and things. Okay, why don't we come over here? We're gonna freeze panes so I can start scrolling down again. How far do we want to go with this? Let's go up to 40. Whoops, I skipped some. That's fine. 28 gives me 18. 30 gives me 28. Isn't this? This is just so fascinating to me. Gives me 5. 34 gives me 10. 36 gives me 12. 40 gives me 12? Really? So we've got, all right. Okay, now let's try this. We're going to take what we've got so far, and we're going to see if we can find some sort of pattern with this. So we're just going to create a scatter plot. Oh my gosh. This is beautiful. It looks so random almost. But this is just, you know, straight math that is making this pattern. Wow. It's got this one that stays really close to the bottom. Remember, like when we get all the way up to 128, we get a 7. And then it's also got this one, these unlucky numbers that are just bad for the pattern. We're all the way up to 36 up here. So, 36 comes from, if we have 38 cards in our deck, that means that we need 36 shuffles. I don't know if you can see that super well, but this is 38 here. It's small text, I'm sorry. But this is 38. This is 36. And, well, you can see that right here. Huh? So potentially, every once in a while, it seems like you need almost as many shuffles as you have cards. There's this line, there's a straight line here of sometimes it's the number of cards minus 2. We've got that happening at 4 and 2. We've got, if you have 6 cards, you need 4 shuffles. 12 cards, 10 shuffles. 14 cards, 12 shuffles. 20 cards, 18 shuffles. 30 cards, 28 shuffles. Oh my gosh, this is so beautiful. Okay. I was expecting all of these points to line up along a simple, neat line. And I was expecting us to be able to, if you have a scatter plot where everything is directly on a straight line, I mean, you can get Excel to tell you what that line is. And in fact, this is making it, it'll even average out. Okay, so this is the average line. And of course, if these lines were all perfectly on a line, then the average line would, you know, be the actual line. And you can get that formula. Gosh, this is so interesting. Wow. I didn't expect this at all. Okay, well, there you go. Um, so obviously the formula, I was expecting a simple formula to be able to calculate this. Like if I give the computer a 40, it spits out a 12. I was expecting this to be a much easier formula to work out, but it's not. We have this whole model that prints it out for us. So this extra credit bit about getting up to 20,000, man. Um, I mean, to actually do this, this is like a brute force method. Uh, so we, so to actually cover exactly what position of every card is up to for a deck of 20,000, we would need to drag this all the way down till this reaches 20,000, and this potentially needs to go all the way up to 19,998 shuffles. And I don't think that I want to do that to my computer. um, because look how, whoops, that's right. I don't want to. I don't want to break it. What? 198. 198? Really? 198 doesn't 198 isn't working. It's going up to 233. Oh, that's because we don't have this. 196. Okay, yeah. See, I would have to drag this all the way out to 20,000. I mean, because we're still getting cards that follow this pattern. Look, it's for 198 shuffles. The answer is 196. Okay, so I'm of course assuming that this pattern holds. It's always the greatest amount is always the deck size minus two, um, and I don't think I can prove that, but empirically that seems to be the case, unless we can, unless you find somebody that. This is just so mind-bogglingly interesting to me. Okay, but that's my whole spiel. Um, why doesn't this say winner here? Oh, right, because it's here. 196. This was a lot of fun. Thank you for joining us for this very, very nerdy. Did anybody join us? I don't know if anybody joined us. Um, okay, well that's fine. I had a lot of fun. Uh, all right, all right. Well, I'll see y'all later. God bless and ciao.